Dear students, in this class we will discuss how prices are determined in a perfectly competitive market. We will explain the features of perfectly competitive market later. But for the time being, we just briefly mention the characteristics of a perfectly competitive market. A perfectly competitive market is characterized by large number of buyers and sellers. Each buyer and seller is very small, independent, and there is no competition between buyers and sellers. Even though the name is perfect competition, there is no competition between buyers and sellers. The second feature is freedom of entry and exit. Buyers and sellers are free to enter the market or exit the market. That means there is no cost to enter and exit. The third feature is homogeneous product. Each and every producer produces the same product, and you cannot distinguish the product of one producer from another producer. And the last, perfect information on the part of both the producers and consumers about the quality of the product, the price of the product, etc., etc. So these are the characteristics of a perfectly competitive market. We will explain these characteristics in detail later. This is just to introduce the concept, that is all. Now we explain how prices are determined in such a market and what will be the quantity bought and sold at the price established in the market. And to explain how prices are determined in a competitive market, we develop the supply-demand model. As we have explained in the previous class, we develop the supply-demand model to explain how prices are determined in a competitive market and also the quantities bought and sold in the established price. Now the demand-supply model is based on the assumption that two kinds of forces are operating in the economy, operating in the market. One is the willingness of buyers to buy at various prices. Second is the willingness of suppliers to supply at various prices. So to develop the market model, we analyze these forces separately. We analyze the forces of demand and supply, the willingness of buyers and sellers separately, and we bring together these forces to explain equilibrium price and equilibrium quantity. That is how equilibrium price and equilibrium quantity is established in a competitive market. We start with what is meant by demand. In the form of a definition, demand is defined as the quantity of a commodity which a person is willing to purchase at various prices during a given period of time. Demand is defined as quantity of a commodity which a person is willing to purchase at various prices during a given period of time. The definition involves two things. One is the desire to purchase. The other one is the ability to purchase. Mere desire to purchase is not demand. Desire must be backed by ability. Now, let me define what is demand function. Demand function means the determinants of demand. The determinants of demand. Our demand function is simply defined as the functional relationship between quantity demanded of a commodity and various factors determining it. Is a functional relationship between quantity demanded of a commodity and various factors determining it. That is the demand function. Now, the quantity of a commodity that an individual is willing to purchase over a specified period of time, the quantity of commodity which a person is willing to purchase during a specified period of time is a function of or depends on the price of the commodity, the prices of the related commodities, that is substitutes and complements, income of the consumer, and individuals' tastes and preferences. Now, symbolically, we write demand function as Q dx is equal to a function of Px, P0, Y and T. Quantity demanded of commodity X is a function of price of X, prices of all the other commodities P0, that is substitutes and complements, income of the consumer Y and taste and preferences of the consumer. This is the demand function. The functional relationship between quantity demanded of a commodity and various factors determining it. The various factors determining it includes price of the commodity, prices of substitutes and complements, income of the consumer, taste and preferences, etc. Now we define individual demand for a commodity. Individual demand for a commodity. Having defined the demand function, we now define the individual demand for a commodity. By varying the price of the commodity while keeping constant the income of the consumer, prices of all the related commodities, and taste and preferences, we will obtain an individual demand schedule. That is, by varying the price of the commodity Px, keeping constant P0, Y and T, we will obtain what is known as the individual demand schedule or individual demand for a commodity. If this individual demand is specified in the form of a table, you will get the individual demand schedule, and its graphical representation is individual demand curve. Its graphical representation is individual demand curve. So Q dx is a function of Px, P0, y, t held constant. A bar above the variable shows that these variables are held constant. Can be written as q dx is a function of Px ceteris paribus. Ceteris paribus means other things remaining the same. Ceteris paribus means other things remaining the same. So quantity demanded of x is a function of price of x alone, keeping all the other factors affecting quantity demanded held constant. The assumption is known as ceteris paribus. This is the individual demand for a commodity. And its graphical representation will give you what is known as the individual demand schedule. Now, if the demand function is linear, we can write it as q dx is equal to a minus bpx. If the demand function is linear, we write it as q dx is equal to a minus bpx. Demand curve can have any shape. We assume for the time being that it is linear. This a and b are known as the constants defining the relationship between price and quantity demanded. A and b are also known as the parameters. They are also known as the coefficients. And a is the y-intercept, b is the slope coefficient. So a is the intercept coefficient, b is the slope coefficient. As an example, consider q dx is equal to 8 minus px. Now, by assigning values to px 0, 8, 1, 7, 8, 0. This is an individual demand schedule. Q dx is equal to 8 minus px, and we can represent this in the form of a graph. Qx here and 8, 8. As the demand curve is linear, 8 minus px, it is a straight line. Individual demand curve is a straight line. And when we know that when px is 0, qx is 8, and when qx is 0, px is 8, like that. Anyway, remember this. Mathematically, when we draw an equation, the dependent variable is on the y-axis, independent variable is on the x-axis. But in economics, while drawing the relationship between price and quantity demanded, we take an independent variable on the y-axis, dependent variable on the x-axis. And I will clarify this point. Anyway, for the time being, remember that demand curve can be a straight line, as is the case here. It can be a smooth curve, or it can have any irregular shape. But usually, the demand curve is negatively sloped. So the only thing required is demand curve will be negatively sloped. Now, to clarify a few more points, suppose that q dx is equal to 12 minus 2px. is a linear demand curve. In this case, by assigning successive values to Px, you will get the corresponding Qx. Px is 0, Qx is 6, Px is 1, then 6, 0, like this. By assigning various values to Px, you have the corresponding what is known as quantities. And if you plot this, this is the individual demand schedule, plot this in the form of a graph, Px, Qx, 6, this point is 12, Qx. Now, this is the demand curve, Px, Qx. Now, in this specification, when Px is 0, the maximum quantity is 6, and this point is known as the saturation point. Even if a commodity is given to you free of cost, you will not be ready to accept more than 6 units because you have the problems of storage, you have the problems of how to dispose the commodity, etc., etc. So the maximum you will keep is, you are willing to keep is 6 units, maybe 6,000, 600. The unit of measurement is not specified here. Anyway, as this example shows, contrary to what we use in mathematics, the dependent variable is taken on the x-axis, independent variable is taken on the y-axis. So we cannot say that 12 is the y-intercept, here 12 is the x-intercept. And what is the slope? The slope of this curve is minus 6 by 12 is equal to minus 0.5. The slope is not equal to minus 2, it is minus 0.5. So, let us see what happens here. Now, given this demand curve, we can write 2px as equal to 12 minus q dx. And px is equal to 6 minus 1 by 2 q dx. Now as you can see, this is quantity demanded is a function of price of x. Here price of x is a function of quantity demanded of x. So this is the inverse of this. Now suppose that I plot this. Now what is the dependent variable? Px. What is the independent variable? Qx. So when Qx is 0, what is Px? Px is 12. Px is, when Qx is 0, when Qx is 0, what is Px? Px is 6 minus here Qx is 12 minus 2px, and this is Px is 6, 12. Now, when when Qx is 0, Px is 6, and when Qx is 12, what I did here is, so now the dependent variable is, the dependent variable is Px, independent variable is Qx. So I take a Qx, what I did here is, so if my equation is Px is equal to 6 minus 1 by 2 Qx, the dependent variable is Px, independent variable is Qx. This is 6, this is 12. Now, if Qx is 0, what is Px? That is 6, the y-intercept. The y-intercept. And what is the slope? The slope is 6 by minus 6 by 12 is equal to minus 0.5. So the question is, if you write q dx is equal to 12 minus 2px, you have to plot this something like this. That is, q dx is equal to 12 minus 2px. So q dx depends on px. When px is 0, it is 12, then 6. So the y-intercept is 12 and the slope is minus 12 by 6 is equal to minus 2. So if your equation is like this, then when you represent it graphically, this is the correct specification. But if your equation is like this, and if you represent this in this form, actually you write the equation like this, but the graph is the inverse of the original equation. And both the slope and intercept are different, even though the demand curve is still negatively sloped. It is a convention in economics, that is why you have such a doubt. Now the question is, if this is the true function, can we derive the inverse of the function? Mathematically, inverse of the function exists if the function is monotonic. Monotonic means the function which increases continuously or decreases continuously. A monotonic function. A function which increases continuously or decreases continuously. In such cases, the inverse exists. So, we write q dx as a function of px and we draw the graph as px is a function of qx. That is why this confusion arises, and this should always be kept in mind. Now, consider a demand function like this. Q dx is equal to 8 minus px. Q dx is equal to 8 minus px or equal to 8 into px raised to minus 1. 8 into px raised to minus 1, or q dx is equal to a by px is equal to a into px raised to minus 1. Now, suppose that you are assigning successive values to px, qx. You give px the value 1, qx is 8, value 2, 4, value 4, 2, value 0, 0 cannot be. So 8, 1, you give the value 8 minus px, 12, sorry, the values I have taken is, 8, 1, 4, 2, 2, 4, 1, 8, like this. Now, if you plot this in the form of a graph, taking px here and qx here, you will get a curve like this as the demand curve. This is a very famous demand curve in economics. It is a rectangular hyperbola. Rectangular hyperbola. It is a rectangular hyperbola. and its characteristics will be discussed later. So for the time being, remember this one characteristics. As you move away from origin towards the x-axis or the y-axis, the demand curve approaches to the x-axis, approaches to the y-axis, but never touches it. So we will say that the demand curve is asymptotic. The demand curve is asymptotic to both x-axis and y-axis. It is a very famous demand curve, and its usefulness will be considered later. Also, if you multiplied q dx into px, you will get it as a constant. Qx into px is the total expenditure on a commodity, and if the demand curve is a rectangular hyperbola, then total expenditure will remain a constant. Now, we have drawn this individual demand function by using the assumption ceteris paribus. Now, it is important to know what is meant by this ceteris paribus assumption. To explain this assumption, suppose that q dx is equal to minus 30 px plus 0.05 y plus 2 p0 plus 40. And suppose that y is equal to 5000, p0 is equal to 25, t is equal to 30. That is, this income, prices of other commodities and ties are kept constant at some fixed values. Then you will get q dx as equal to minus 30 px plus 0.05 into 5000 plus 2 into 25 plus 4 into 30. If you do the calculations, you will get q dx as equal to 420 minus 30 px. And remember this point. Where is the influence of the factors held constant? In the intercept. If there is a change in the value of any of the factors, income, prices of other commodities, tastes and preferences of the consumer, etc., then the intercept will change. The slope is minus 30, it will remain constant, and the entire demand curve shifts to the left or to the right. So remember this, we classify the factors affecting the demand for a commodity into two. One, price, a change in the price, and factors other than price. So let us see what is the importance of this distinction. To explain the importance of this distinction, we have to discuss how the individual demand curve shifts. Remember this, as I told you, if any of the factors held constant changes over time, the individual demand curve will shift. And this is referred to as change in demand. If the demand curve shifts towards the right, it is increase in demand, and it shifts towards the left, it is decrease in demand. And this must be contrasted with a movement along the demand curve, which is known as change in quantity demanded. Change in quantity demanded, an increase in quantity demanded, and a decrease in quantity demanded. So a movement along the demand curve is due to a change in price. If price increases, quantity demanded decreases. If price decreases, quantity demanded increases. This is known as change in quantity demanded. It is contrasted against change in demand. Change in demand is due to factors other than price. Factors other than price. So we have a price as the factor which causes movement along the same demand curve, and factors other than price are the shift factors. As an example, if the money income of the individual increases, then the demand curve will shift towards the right. On the other hand, if the money income decreases, the demand curve will shift towards the left. And if the money income increases, and if more of the commodity is purchased at the same price, such a commodity is known as a normal good. As income increases, quantity demanded also increases. The commodity under question is a normal good. And we will see more about this later. Now, to explain the difference between these two, you consider a demand curve dx. When the price was 4, he used to purchase 2 units. When the price decreases to 2, he purchases 4 units. This movement from this point to this point is nothing but an increase in quantity demanded. If the initial price was 2 and if it increases to 4, it is a decrease in quantity demanded. Now suppose that the income of the consumer increases. As a result, the demand curve is shifted towards the right as d dash x. And for the same price, now he purchases 6 units. For the same price, he purchases 6 units. This movement from this point to this point is an increase in demand. So when we say that the demand for a commodity has increased, what we mean is the demand curve shifts towards the right. The demand curve shifts towards the right. Because demand increases means for the same price you are purchasing more. You are purchasing more. So this difference must be kept in mind always. That is, movement along the same demand curve is change in quantity demanded. It is due to price. Change in demand is due to factors other than price. It is known as change in demand. Change in demand versus change in quantity demanded. Change in demand itself is increase in demand and decrease in demand. Change in quantity demanded is increase in quantity demanded and decrease in quantity demanded. And we will see more about this at a later time. We will see more about not only income, we have to consider the effect on quantity demanded when there is a change in the price of related commodities, substitutes and complements, for getting more understanding about the nature of the relationship between commodities. These points will be discussed later.